Welcome back, sleepy science facts. Today, we continue our peaceful journey into Earth, Part 2. In this chapter, we'll drift a little deeper into our planet's quiet wonders, exploring the forests, oceans, mountains, and hidden places that make our world so unique. So relax, settle in, and let the gentle beauty of Earth unfold around you. Make sure to like, subscribe, and hit the bell for more sleepy science facts. And remember, read the first command for support. This planet is more water than land, an ocean world with continents scattered across its surface like floating islands. Without water, Earth would be just another rocky planet orbiting the sun. With water, it is alive. This is the ocean planet, sculpted by water, driven by cycles older than mountains, alive with mysteries that reach from the surface to the deepest abyss. To understand Earth, you must see it as a living world, not alive in the biological sense, but alive in its movement, in its breath, in the restless shifting of its crust. The ground beneath our feet feels solid and eternal, yet it is anything but. Continents move, oceans expand and shrink, mountains rise and crumble, and the very surface of Earth transforms over millions of years like a slow-motion dance too vast for any human lifetime to witness. But the evidence is everywhere. In the arc of a mountain range, in the fold of a valley, in the shape of a coastline, in the fossils of once tropical plants now found in frozen Antarctica, in the rugged scars left by earthquakes that reshape entire landscapes in moments. Earth's continents have wandered across the globe for billions of years, drifting over a layer of molten rock like colossal rafts. This motion, known as plate tectonics, is one of the most powerful and defining forces shaping the planet. It is responsible for earthquakes, volcanoes, mountain building, and the slow creation of land itself. Without plate tectonics, Earth would likely resemble Mars, static, cold, and geologically silent, lacking the cycles that replenish minerals and stabilize climate. Instead, we live on a world that continuously renews itself. Imagine Earth 3 billion years ago. The surface was new, young, intensely hot. The first continents were small, rough, and barren, mere fragments of crust floating on a sea of magma. Over time, these fragments collided again and again, merging into larger landmasses. Entire continents have formed and broken apart multiple times throughout Earth's history. Scientists believe that every 400 to 600 million years, all continents gather into a single massive supercontinent. It's happened several times. Columbia, Rodinia, Pannotia, and most famously, Pangaea, the supercontinent that existed about 300 million years ago. Picture it, one enormous landmass stretching across the globe like a colossal puzzle piece, surrounded by a vast global ocean. Dinosaurs would one day walk across it. Forests of towering ferns and early reptiles would thrive. Then, slowly, inexorably, Pangaea began to crack apart. The pieces we now call Africa, South America, Antarctica, India, North America, Eurasia, and Australia drifted away like separate stories written on the same ancient parchment. Even today, the continents continue their quiet migration. Africa is slowly moving northward, toward Europe, narrowing the Mediterranean Sea. Australia is drifting toward Asia. The Pacific Ocean is shrinking while the Atlantic widens. North and South America move further away from Africa every year, about the same speed your fingernails grow. Though slow, these movements release enormous power. When plates collide, mountains rise. The Himalayas, the tallest mountains on Earth, were born when India slammed into Eurasia 50 million years ago, and they are still rising today. When plates pull apart, molten rock rises to fill the gap, forming new crust. The Mid-Atlantic Ridge, a mountain range hidden beneath the Atlantic Ocean, marks the birthplace of new oceanic crust, created continuously as North America and Europe drift apart. But plate tectonics is not just about destruction or creation. It is the reason we have continents at all. Without this constant recycling of crust, continents would erode away over time. Instead, they are renewed by the slow push of magma, the rise of mountain ranges, and the eruption of volcanoes that build new land, grain by grain. Volcanic islands like Hawaii emerge from deep beneath the ocean, formed by hot spots in the mantle that push molten rock to the surface. Then, over thousands of years, life arrives, plants first, carried by winds and birds, then animals, creating ecosystems on land that did not exist before. Continents also shape life in profound ways. Their movement has separated species, isolated populations, and driven evolution. Millions of years ago, when South America was isolated, it became home to unique creatures, giant sloths, terror birds, armadillos as large as cars. When continents reconnected, species migrated and competed, reshaping ecosystems forever. The distribution of animals today, kangaroos in Australia, lions in Africa, bison in North America, reflects the wandering history of continents over deep time. But the continents are not just scars of ancient collisions. They are dynamic landscapes sculpted by weather, rivers, glaciers, and wind. Mountains eventually crumble into sediment carried by rivers to the sea. Valleys widen, coastlines shift, deserts form where oceans once existed. The Sahara Desert, now one of the driest places on Earth, was once covered in lakes and grasslands, home to crocodiles, hippos, and early humans. Even today, faint cave paintings in the Sahara show scenes of swimming and lush forests that no longer exist. Earth's continents are in many ways survivors. They have endured asteroid impacts, global ice ages, mass extinctions, and volcanic eruptions. They hold the history of every plant, every animal, every human civilization. They carry the minerals that fuel industries, the soil that grows crops, the energies that power cities. And beneath them flows something ancient and immense, the molten mantle, circulating slowly like a hidden bloodstream that carries heat from deep within Earth to the surface. This heat is the engine of plate tectonics. Without it, Earth's continents would freeze in place, the climate would stagnate, and life might never have evolved beyond simple forms. But with tectonics, Earth remains young, active, ever-changing. Stand on any mountain, any plain, any beach, and you are standing on the product of billions of years of movement. The ground beneath you has traveled across oceans, collided with other lands, risen and fallen, transforming again and again. Earth is not a static world, it is a restless one, and its continents are the living record of its long, ever-changing story. We often take the air around us for granted, inhaling it without thought, exhaling without reflection. Yet this invisible envelope, the atmosphere, is as vital to life as water or soil. It is Earth's first line of defense, its climate regulator, its messenger of weather, and the delicate skin that separates life from the cold, void expanse of space. To truly understand our planet, we must look upward, beyond the forests, mountains, and oceans, and explore the ever-shifting layer of gases that wraps the Earth like a living veil. The atmosphere did not appear overnight. When Earth formed 4.5 billion years ago, the young planet was a molten sphere, bombarded by meteors, spewing volcanic gases, and lacking the oxygen-rich air we breathe today. Early atmospheres were thick with carbon dioxide, nitrogen, methane, and water vapor, poisonous to humans, but the perfect cradle for early life. Oceans absorbed some gases, volcanic eruptions released more, and life slowly began to alter the chemistry of the sky. Photosynthetic microorganisms, cyanobacteria, changed everything. They pulled carbon dioxide from the atmosphere, releasing oxygen as a byproduct. This process, beginning billions of years ago, led to the Great Oxidation Event, a dramatic increase in atmospheric oxygen that transformed the planet. The sky we now take for granted, the air that fills our lungs, is the legacy of these ancient microbes. Today, Earth's atmosphere is a complex, multi-layered system. The troposphere, closest to the ground, is where weather unfolds. Clouds form, storms rage, winds blow, and birds soar. Above it, the stratosphere houses the protective ozone layer, which shields life from harmful ultraviolet radiation. The mesosphere burns meteors before they reach the surface, and the thermosphere stretches towards space, glowing with auroras and interacting with solar winds. Each layer is critical, each layer dynamic, constantly in motion, yet all interconnected in a delicate balance. The atmosphere is not just a protective barrier, it is the engine of climate and weather. Winds circulate heat from equator to poles. Ocean currents interact with the air to form monsoons, cyclones, and hurricanes. Mountains influence rainfall, deserts arise where air descends dry. Clouds act as mirrors and blankets, reflecting sunlight and trapping heat. Even the smallest changes in the composition of gases can alter the climate, as human industrial activity has recently shown. Weather is the atmosphere in motion. Imagine standing on a cliff overlooking the ocean. The wind whips salt spray against your skin. Clouds gather on the horizon, a storm brewing as low-pressure systems and warm, moist air collide. These movements are powered by the sun, filtered through the complex geometry of land and sea, creating local climates, global patterns, and the rhythms of life itself. Every raindrop that nourishes a forest, every gust of wind that carries seeds, every snowflake that blankets the polar regions is a product of the atmospheric machinery. The atmosphere also enables life to flourish beyond our immediate perception. Oxygen, nitrogen, carbon dioxide, and trace gases circulate continually, sustaining plants, animals, and humans alike. Without this thin layer of gas, temperatures would swing wildly between scorching days and freezing nights, and life as we know it would be impossible. Even the gentle pressure we feel when breathing is a silent reminder of the delicate balance that allows us to exist. And yet, the atmosphere is not impervious. Human activity has begun to alter it. Carbon dioxide concentrations have risen, trapping heat and warming the planet. Methane emissions from agriculture add to greenhouse effects. Aerosols influence cloud formation and sunlight penetration. The result is a climate system under stress, with shifting weather patterns, stronger storms, melting glaciers, and rising seas. The atmosphere is a living system, responsive and sensitive, warning us of imbalance and change. Beyond the science, The atmosphere has also shaped human imagination. It paints the sky in colors at dawn and dusk, produces auroras in polar regions, and carries whispers of distant lands through prevailing winds. It is both protective and poetic, scientific and spiritual, a dynamic, unseen ocean above the surface of our world. To study the atmosphere is to see Earth from a new perspective. It is to realize that life exists not just on the ground or in the oceans, but within the sky itself. Every storm, every cloud, every gust of wind is part of a vast, interconnected system that has nurtured life for billions of years. The atmosphere is Earth's breath, the whispering veil that makes the planet habitable, the silent guardian between us and the void. Stand beneath the endless blue, watch the clouds drift, feel the wind on your face, and you are witnessing one of the most profound forces on Earth. A living system that sustains, protects, and shapes every creature that calls this planet home. Without it, life would be unthinkable. With it, Earth remains a vibrant, dynamic world, a miracle suspended in space. To step outside is to enter a complex, interconnected web of life. Every tree, every blade of grass, every insect, bird, and mammal exists not in isolation, but as a part of an intricate network of interactions that scientists call ecosystems. These systems are the veins and arteries of our planet, channels through which energy flows, nutrients cycle, and life persists. Earth is not merely a collection of species, but a living, breathing organism composed of countless overlapping and interdependent communities. Ecosystems come in staggering diversity, from the frozen tundras of the Arctic to the humid tropical rainforests of the Amazon, from coral reefs teeming with fish and invertebrates to the windswept deserts of the Sahara. Each ecosystem is finely tuned to its environment. Life adapts to temperature, light, moisture, soil, and predators. Each species occupies a niche, a role that ensures survival while maintaining balance. Remove one piece, and the ripple effects can be catastrophic. Consider the tropical rainforest, the most biodiverse ecosystem on Earth. In these forests, trees reach for the sun while vines twist and climb, epiphytes perch high above, and the forest floor is a mosaic of decaying leaves, fungi, and seedlings. Insects pollinate flowers, birds disperse seeds, predators keep herbivores in check, and decomposers recycle nutrients back into the soil. Every action, every relationship, every survival strategy is part of a delicate balance maintained over millions of years. Remove the pollinators, and fruit-bearing trees fail. Remove apex predators, and herbivore populations explode, devastating plant life. The rainforest functions as a tightly interwoven tapestry of life. Similarly, oceans are vast ecosystems where currents, temperature, and nutrient availability dictate life patterns. Phytoplankton, microscopic yet mighty, form the base of the marine food chain, sustaining fish, mammals, and birds. Coral reefs, often called the rainforests of the sea, support tens of thousands of species. Sharks patrol the oceans, controlling populations of other predators. Deep sea vents host life forms entirely independent of sunlight, relying instead on chemical energy in an alien-like ecosystem. Each ecosystem, terrestrial or aquatic, is a miniature world governed by the same rules. Energy flows, nutrients cycle, and survival depends on balance. The concept of the food chain illustrates this principle. Energy captured from the sun by plants moves through herbivores, carnivores, and decomposers in an endless cycle. Yet in reality, life is less a simple chain and more a web, a network of interactions where each species influences many others. The extinction of a single species can resonate throughout the ecosystem, altering predator-prey dynamics, changing plant distribution, and even affecting climate locally. Earth's life is not modular, it is holistic. It is a symphony in which every note matters. Humans, too, are a part of this web. For millennia, our survival has depended on understanding and participating in ecosystems. Early humans relied on hunting and gathering, learning which plants were edible, which animals dangerous, and which habitats were safe. Agricultural societies manipulated ecosystems by planting crops and domesticating animals, fundamentally reshaping the balance of nature. Today, industrialization, urbanization, and climate change have altered ecosystems on a global scale, creating both challenges and opportunities for coexistence. Despite the fragility of ecosystems, life demonstrates resilience. Forests regrow after fires, wetlands recover from floods, and species adapt to new pressures. Evolution itself is a testament to life's ability to find equilibrium, even under constantly changing environmental conditions. But resilience has limits. Rapid changes caused by human activity, deforestation, pollution, overfishing, and global warming push ecosystems beyond their natural capacity to adapt, threatening the stability of the very systems that sustain us. Earth's ecosystems are also crucial regulators of climate and resources. Wetlands store water and filter pollutants. Forests absorb carbon dioxide and release oxygen. Oceans circulate heat, distribute nutrients, and moderate temperature. Even soil is an ecosystem, teeming with bacteria, fungi, and microfauna that break down organic matter, enrich nutrients, and maintain fertility. Every ecosystem is simultaneously a habitat, a regulator, and a contributor to the planet's health. Studying these systems reveals patterns that are both beautiful and instructive. Seasonal migrations, reproductive cycles, predator-prey interactions, symbiotic relationships, these are all examples of nature's rhythms. They demonstrate that life is not chaotic, but orchestrated, with feedback loops, redundancies, and emergent properties that allow ecosystems to sustain themselves over millennia. Perhaps most striking is the interconnectedness of life. A forest in Brazil can influence rainfall in North America. Coral reefs in the Pacific affect fish populations thousands of miles away. Deforestation or pollution in one part of the world can trigger cascading effects far beyond its borders. Earth is a single, living planet, where ecosystems are threads in a web so intricate that no species, no ecosystem, no biome exists in true isolation. Understanding this interconnectedness is both humbling and empowering. It reminds us that humans are not separate from nature, but embedded within it. Our choices ripple outward, affecting not only the immediate environment, but the global balance of life. Conservation, restoration, and sustainable management are not acts of charity. They are acts of survival, both for our species and for the countless others with whom we share this planet. In the dance of life, ecosystems are the stage, the performers, and the music all at once. They are the tangible expression of Earth's evolutionary journey, the product of billions of years of interaction, adaptation, and resilience. To protect them is to honor the deep time processes that have shaped our world and to safeguard the intricate network that sustains all life. Earth, in every sense, is alive, not because it breathes in lungs or walks on legs, but because life itself pulses through every leaf, every wave, every microbe, every mountain, and every gust of wind. Ecosystems are the visible veins of this life, and through them, we glimpse the astonishing complexity, balance, and beauty of our planet. Climate is the story of Earth written in wind, rain, ice, and fire. It is the invisible hand that shapes every ecosystem, every river, every forest, every desert, and every ocean. It is both gentle and violent, a sculptor of landscapes and a driver of life's evolution. Without climate, there would be no forests to shelter birds, no rivers to sustain civilizations, no seasons to guide migration. Climate is not a single event, but a system of patterns and rhythms unfolding over centuries, millennia, and even millions of years. To understand Earth's climate, one must think in deep time. For billions of years, the planet's temperature has fluctuated within narrow bands that allowed life to flourish. Yet even minor shifts in heat, precipitation, or ocean currents can ripple across the globe, producing dramatic changes. Earth has experienced ice ages, periods of intense glaciation when ice sheets stretched across continents, trapping oceans in frozen prisons. It has also experienced hothouse periods when tropical conditions extended to the poles, reshaping flora and fauna and driving evolution in unexpected directions. These shifts are influenced by numerous factors. The tilt of Earth's axis, the shape of its orbit, solar intensity, volcanic activity, and ocean currents all play a role in determining climate patterns. The planet is a dynamic system, constantly adjusting as heat moves from equator to poles, as moisture cycles between ocean and land, and as energy is absorbed, reflected, or radiated back into space. This intricate balance is what has allowed life to adapt, survive, and thrive over billions of years. But climate is more than a scientific abstraction. It is intimately tied to every living organism. Trees grow according to rainfall patterns, fish migrate with ocean temperatures, and birds time their breeding to the arrival of spring. Humans have adapted to climate as well, developing agriculture, settling along rivers, and constructing cities to withstand seasonal changes. Civilization itself is inseparable from climate, yet human activity has begun to alter the delicate equilibrium that has sustained life for millennia. Over the past 2 centuries, industrialization has introduced unprecedented amounts of greenhouse gases into the atmosphere. Carbon dioxide, methane, and nitrous oxide trap heat, slowly warming the planet. Glaciers melt, sea levels rise, storms intensify, and weather patterns shift. Coral reefs bleach, forests dry, and ecosystems struggle to adapt. Climate is no longer purely natural. It is now shaped by human hands, a reminder that our species has both the power to protect and the power to destabilize the planet. Understanding climate requires a holistic view. It cannot be reduced to simple averages of temperature or rainfall. It is the interaction of atmosphere, oceans, land, ice, and life. El Niño and La Niña, monsoons, jet streams, polar vortexes, all are expressions of the complex feedback loops that govern the planet's energy balance. Climate is both local and global, immediate and slow, predictable in some ways and chaotic in others. It is a system of staggering complexity, yet one that we are only beginning to comprehend. Studying the climate of the past is equally illuminating. Ice cores, tree rings, sediment layers, and fossils provide evidence of Earth's historical temperatures and environmental conditions. They reveal periods of stability and instability, of thriving ecosystems and mass extinctions. By examining these records, scientists can predict potential futures and guide humanity toward sustainable choices. Climate is both history and prophecy, a mirror of what has been and a window into what might come. The consequences of climate change are far-reaching. Melting ice in Greenland and Antarctica threatens coastal cities. Warming oceans disrupt currents and fisheries. Shifting rainfall patterns affect agriculture and water supplies. Extreme weather events endanger human life and infrastructure. The delicate dance that allowed life to flourish for millions of years is now out of rhythm, and the clock is ticking. Yet climate is also a source of wonder. The auroras dancing in polar skies are powered by atmospheric interactions. Monsoon rains transform deserts into lush landscapes. Snowfall in the high mountains creates rivers that nourish valleys for thousands of kilometers. Winds shape sand dunes, carve cliffs, and spread seeds across continents. Climate is a force of creation as much as a challenge, a driver of evolution, a sculptor of the Earth's ever-changing face. In essence, climate is the heartbeat of the planet. It is the rhythm that guides life, shapes landscapes, and connects ecosystems across the globe. To understand Earth, we must listen to its pulse, watch its cycles, and recognize our role in maintaining its delicate balance. For the health of the planet and the survival of life, climate is not a distant abstraction. It is the very essence of existence on Earth. Beneath the solid crust of Earth lies a hidden, molten world, a fiery heart that pulses with unimaginable energy. Volcanoes are its surface expression, dramatic openings through which the planet reveals its inner fury. They are destructive and creative, terrifying and beautiful, capable of reshaping landscapes, altering climates, and giving birth to new land. To understand Earth fully, one must witness its fires and feel the power of its molten blood. Volcanoes form where tectonic plates collide, separate, or slide over hot spots in the mantle. When plates converge, one may be forced beneath the other in a process called subduction. The descending plate melts, generating magma that rises through cracks in the crust to create volcanoes. Along divergent boundaries, plates pull apart, allowing molten rock to emerge from the mantle, forming mid-ocean ridges and volcanic islands. Hot spots, meanwhile, punch through plates far from boundaries, creating chains of islands such as Hawaii. The violence of an eruption is awe-inspiring. Lava fountains, pyroclastic flows, and ash clouds can destroy towns in minutes, yet the same eruptions build mountains, create fertile soils, and reshape coastlines. Consider Mount Vesuvius, whose eruption in 79 AD buried Pompeii and Herculaneum, preserving their stories for millennia. Or Mount St. Helens in 1980, which flattened forests and altered rivers, yet led to ecological regeneration. Volcanoes are both destroyers and creators, reminders of Earth's dynamic power. Volcanic activity is also a driver of climate. Large eruptions inject ash and sulfur dioxide into the atmosphere, reflecting sunlight and temporarily cooling the planet. They release gases that contribute to greenhouse warming over longer timescales. Ancient eruptions, like the Deccan traps in India or the Siberian traps, are linked to mass extinctions, demonstrating the profound influence of volcanic activity on life itself. Yet volcanoes are not merely instruments of destruction, they are life givers. Lava flows, though initially barren, eventually break down into rich soils that nurture forests and crops. Islands born from volcanic activity, such as Iceland, the Galapagos, and the Azores, become havens for biodiversity, each eruption writing a new chapter in the story of life. Even human civilizations have thrived in volcanic regions. The fertile soils of Java, Naples, and the Andes support dense populations, their lives intertwined with the rhythms of the volcano. The study of volcanoes is both ancient and modern. Early humans feared and revered them, interpreting eruptions as acts of gods. Today, scientists monitor seismic activity, gas emissions, and ground deformation to predict eruptions and mitigate disaster. Understanding volcanoes provides insights into Earth's interior, the movement of tectonic plates, and the evolution of landscapes over millions of years. Volcanoes are not isolated phenomena. They are intimately connected to other systems. Earthquakes often precede eruptions. Climate is influenced by volcanic gases, and ecosystems adapt to repeated disturbances. Even the oceans bear volcanic influence. Undersea eruptions create new habitats, alter water chemistry, and drive hydrothermal ecosystems that host life independent of sunlight. Volcanoes demonstrate that Earth's internal energy is inseparable from its surface, atmosphere, and biosphere. The imagery of volcanoes is etched into human imagination. Lava glowing red against the night sky, ash clouds stretching hundreds of kilometers, thunderous eruptions shaking the ground, all inspire awe and fear. Yet beneath the spectacle lies a scientific story, a planet alive, constantly reshaping itself, revealing the processes that sustain its continents, oceans, and atmosphere. Volcanoes remind us that Earth is not passive. It is not static. It is alive with energy, slowly and violently rearranging itself over millennia. The ground beneath us is a thin crust over a churning, molten interior, a fragile veneer atop forces that could, in moments of eruption, remake the world. And yet, these same forces create new life, new landscapes, and new opportunities for adaptation and growth. To stand near a volcano is to feel the pulse of Earth's fiery heart. It is to witness a planet breathing in heat, pressure, and molten rock. It is to confront the raw power that has shaped every mountain, every island, every valley, and every horizon. Volcanoes are a testament to Earth's dynamism, a reminder that the world we inhabit is the product of forces both destructive and creative, ongoing for billions of years and continuing today. Earth's fire is not just beneath our feet. It is in its evolution, in its landscapes, and in the cycles of life that emerge from the chaos. Volcanoes are Earth's storytellers, writing in lava and ash the chronicles of a planet that never rests. Beneath the seemingly solid ground, Earth is in constant motion. Mountains rise, oceans shift, and continents drift, all silently shaping the surface over millions of years. But sometimes, this movement announces itself with sudden dramatic force, earthquakes. These are not merely geological events. They are the planet's way of releasing tension. a reminder that the crust beneath our feet is neither fixed nor permanent. Earthquakes tell the story of a restless planet, a narrative written in trembling soil, ruptured rock, and seismic waves that race through the Earth's interior. Earthquakes originate along fault lines, fractures in the crust where tectonic plates interact. These plates may collide, slide past one another, or pull apart, and as they do, stress accumulates. For years, decades, or even centuries, the stress builds silently, bending and straining the rocks. Then, in an instant, the stress exceeds the strength of the rocks, and the energy is released in a sudden slip along the fault. The ground shakes, buildings collapse, rivers change course, and landscapes are altered in moments. This is the raw power of plate tectonics made visible. The energy of earthquakes travels in seismic waves. Primary waves move fastest, compressing and expanding the ground in a push-pull motion. Secondary waves follow, moving the ground side to side. Surface waves ripple across the earth, causing the most damage to structures. Instruments called seismometers detect and measure these waves, allowing scientists to locate epicenters, calculate magnitude, and study the dynamics of Earth's interior. Every tremor tells a story of movement, of pressure, of a planet continuously reshaping itself. Earthquakes have shaped both the physical and cultural landscapes of our planet. They have created mountains, triggered tsunamis, and altered river courses. Cities have risen and fallen in their wake. Ancient civilizations recorded earthquakes in myth, attributing them to gods or cosmic forces, while modern science seeks to understand, predict, and mitigate their impact. Places like Japan, Indonesia, California, and Chile exist on the front lines of seismic activity, their societies adapted to the inevitability of the Earth's trembling. Some earthquakes are minor, barely noticeable, while others are catastrophic. The 1960 Valdivia earthquake in Chile, the largest recorded in modern history, released the energy equivalent of billions of tons of TNT, reshaping coastlines and generating tsunamis that traveled across the Pacific Ocean. In contrast, frequent small tremors, imperceptible to humans, continuously mold landscapes, shifting mountains, and slowly altering valleys over millennia. This juxtaposition of subtle and violent motion underscores the dynamic nature of the planet. Earthquakes are intimately connected with other geological phenomena. They often accompany volcanic eruptions, result from magma movement, and can trigger landslides. Their energy echoes through the lithosphere, revealing hidden structures deep within the earth, ancient faults, subducted plates, and the boundaries of tectonic slabs. Studying earthquakes provides insights not only into hazards, but also into the deep processes that drive the evolution of continents and ocean basins. Humans experience earthquakes in immediate, tangible ways. Buildings sway, roads crack, and lives are disrupted. Yet the same energy shapes the Earth's surface over vast timescales. The towering Himalayas, the deep valleys of California's San Andreas Fault, and the rifted landscapes of East Africa are all products of accumulated seismic activity over millions of years. Earthquakes are both destroyers and sculptors, a natural reminder of the impermanence of the ground beneath our feet. Modern technology allows us to monitor and sometimes predict earthquakes, but the forces involved remain immense and unpredictable. The planet's crust is not a static shell. It is a living, shifting mosaic, and earthquakes are its voice. Sudden, powerful and eloquent in their warning. They remind us that, for all our engineering and understanding, we inhabit a world far larger and more dynamic than our human lifespans can fully encompass. Earthquakes are the trembling heartbeat of the planet, the subtle and violent pulse of tectonic energy that continues day and night, year after year. To study them is to listen to Earth's hidden movements, to feel its restlessness, and to recognize that the seemingly stable landscapes of our planet are part of a continuum of motion stretching back billions of years and extending far into the future. The ground beneath us is never truly still. It is alive, shifting, and speaking through the language of earthquakes. In the frozen regions of our planet, ice reigns supreme. Glaciers, ice sheets, and polar caps are not simply blocks of frozen water. They are powerful forces that sculpt landscapes, regulate climate, and preserve Earth's history. Though often remote and inhospitable, these frozen realms are integral to the planet's balance, holding clues to past climates, influencing ocean currents, and shaping life both locally and globally. Glaciers form where snow accumulates faster than it melts, compacting over years into dense ice that flows under its own weight. Unlike rivers, glaciers move slowly but inexorably, carving valleys, transporting boulders, and reshaping mountains. The iconic U-shaped valleys of Yosemite, the fjords of Norway, and the sweeping plains of Canada are all the work of ancient ice, moving with patient yet unstoppable force. These frozen rivers are both destroyers and creators, grinding rocks into fine sediments and depositing fertile soils that nourish ecosystems once they retreat. Earth's largest ice sheets, in Antarctica and Greenland, contain the vast majority of its fresh water. They are immense, stretching millions of square kilometers and averaging over 2 kilometers thick. These ice masses act as climate regulators, reflecting sunlight and maintaining cooler global temperatures. They also serve as reservoirs of history. Within their layers lie trapped air bubbles, pollen, ash, and isotopes that provide a chronological record of Earth's atmosphere and climate over hundreds of thousands of years. By drilling deep cores, scientists can reconstruct past ice ages, greenhouse periods, and even the impact of volcanic eruptions on global temperatures. Glacial movement is slow but relentless. As glaciers flow, they erode underlying rock, transport massive amounts of sediment, and deposit moraines, ridges of debris that mark their past reach. The advance and retreat of glaciers have repeatedly reshaped continents, carved out lakes, and influenced sea levels. During the last glacial maximum, around 20,000 years ago, ice sheets covered much of North America, Europe, and Asia, forcing humans, animals, and ecosystems to adapt, migrate, or perish. These frozen expanses have been both barrier and cradle, shaping the evolution and migration of countless species. Glaciers are also climate indicators. Changes in their mass and extent signal shifts in temperature and precipitation. In recent decades, glaciers worldwide have been retreating at unprecedented rates due to global warming. This melting contributes to rising sea levels, threatens freshwater supplies, and destabilizes ecosystems dependent on glacial meltwater. Rivers fed by glaciers, such as the Ganges, Indus, and Colorado, provide life for millions, illustrating how ice connects distant mountains to human survival across continents. The polar regions, too, play a critical role in Earth's climate system. Sea ice influences ocean circulation by altering salinity and temperature, while ice sheets store massive amounts of fresh water, buffering against rapid sea level changes. Polar ecosystems are finely tuned. Penguins, seals, polar bears, and countless microorganisms depend on stable ice for survival. Even tiny changes in ice cover can cascade through the food chain, affecting life thousands of kilometers away. Glaciers and ice are also geological storytellers. Striations on bedrock, glacial erratics, and drumlins, small hills formed by ice movement, preserve the memory of ice ages long past. Their advance and retreat record the dynamic interplay between Earth's climate, atmosphere, and tectonics. From the Alps to the Andes, glaciers are monuments of time, patiently etching Earth's history into its very surface. Beyond science, ice has a profound aesthetic and emotional impact. The auroras dancing above polar skies, the silent blue caverns inside glaciers, the towering icebergs drifting in frigid seas, they inspire awe and reflection. These frozen landscapes remind us of Earth's extremes, the delicate balance that allows life to exist in one part of the planet while the other remains locked in ice. Yet, ice is fragile. Rising global temperatures threaten to dismantle these frozen fortresses. Melting glaciers release freshwater that can disrupt ocean currents, accelerate sea level rise, and displace communities. The loss of ice is not just a local event, it is a planetary signal, a warning that Earth systems are interconnected, sensitive, and vulnerable to change. Glaciers and ice, though often distant from human perception, are essential chapters in the story of Earth. They sculpt landscapes, regulate climate, preserve history, and sustain life. They remind us of the power of slow, persistent forces, forces that move mountains, carve valleys, and shape the planet over eons. In ice, we see both the fragility and resilience of Earth, a frozen testament to the dynamic, interconnected systems that sustain our world. Covering more than 70% of Earth's surface, the oceans are the planet's vast, living arteries. They are at once serene and violent, placid and tempestuous, calm and immeasurably deep. Oceans regulate climate, sustain life, and connect continents through currents that circulate heat, nutrients, and energy across the globe. They are Earth's blue heart, beating rhythmically, silently, yet profoundly, influencing every living system on the planet. The oceans are not mere bodies of water, they are complex, layered ecosystems. From sunlit surface waters where photosynthetic plankton thrive, to the twilight zone where light fades, to the deep abyssal plains and hydrothermal vents of the ocean floor, life has adapted to the full spectrum of conditions. Coral reefs, often called the rainforests of the sea, support tens of thousands of species in intricate symbiotic relationships. Open oceans teem with fish, mammals, and invertebrates, while the deep sea hosts life that thrives without sunlight, powered by chemicals seeping from the Earth's mantle. Oceans are also the engine of Earth's climate. They absorb solar energy at the equator and redistribute it through currents like the Gulf Stream, moderating temperatures across continents. They store vast amounts of carbon dioxide, buffering the atmosphere and mitigating extreme climate changes. Phytoplankton, microscopic yet mighty, photosynthesize in the upper layers, producing oxygen and forming the foundation of the marine food web. Oceans are, in many ways, the lungs and thermostat of our planet. Tides, waves, and currents are manifestations of forces interacting on a planetary scale. The moon and sun create tides, generating the rhythmic rise and fall of water along coastlines. Winds sculpt surface currents, while density differences caused by temperature and salinity drive deep ocean circulation, known as the thermohaline conveyor belt. This global system moves heat and nutrients through the oceans, influencing weather, supporting fisheries, and sustaining ecosystems thousands of kilometers from their origin. The geological role of oceans is equally profound. Subduction zones along the ocean floor recycle crust back into the mantle, while mid-ocean ridges create new seafloor. Volcanic islands emerge from beneath the waves, hydrothermal vents support unique life, and sediments accumulate over millennia, recording the history of Earth's climate and life. Oceans are both creators and archivists, shaping continents and preserving memory beneath their waves. Human civilization is inseparable from the oceans. Coastal settlements, trade routes, and fisheries have depended on the bounty of the seas for millennia. Oceans provide food, transportation, recreation, and a source of inspiration and wonder. Yet human activity has also imposed threats. Overfishing, pollution, plastic accumulation, acidification, and warming waters disrupt ecosystems and jeopardize the services oceans provide. The health of the oceans is a mirror of the planet's health, and their decline has consequences that ripple across both nature and humanity. Oceans are also centers of mystery. Despite centuries of exploration, the deep sea remains largely uncharted. Giant squid, bioluminescent fish, and ecosystems around hydrothermal vents hint at a world more alien than any imagined science fiction. The abyssal plains, trenches like the Mariana, and mid-ocean ridges reveal a dynamic, powerful environment where tectonics, chemistry, and life intertwine in ways we are only beginning to understand. Storms and waves demonstrate the energy of the oceans. Hurricanes, cyclones, and typhoons draw power from warm ocean waters, releasing energy with devastating consequences. Tsunamis, generated by undersea earthquakes or landslides, remind us of the ocean's ability to act as both giver and taker of life. Every wave, every current, every eddy is part of a global system connecting the polar ice to the tropics, the seafloor to the clouds above. To study the oceans is to understand Earth's circulatory system, climate regulator, and life-sustaining engine. The interplay between water, heat, and life forms a complex network, balancing global temperatures, supporting ecosystems, and linking continents. Oceans are alive, not in the conscious sense, but as dynamic, interconnected systems that define our planet's rhythm and vitality. Standing at the edge of the sea, gazing into the horizon, one feels both small and connected. The ocean's vastness reminds us of the scale of Earth, of forces beyond our comprehension, and of life's resilience in adapting to shifting conditions. These waters, ancient and ever-changing, are a testament to the planet's dynamic equilibrium, a blue heart beating silently beneath the sun and moon, sustaining life across the globe. Water on Earth flows, pools, and sustains life in countless forms. While oceans dominate the planet's surface, it is freshwater, rivers, lakes, streams, and underground aquifers that shapes landscapes, nourishes ecosystems, and supports civilizations. These waterways are Earth's veins, delivering nutrients, sculpting valleys, and sustaining life from the smallest microorganism to the largest human metropolis. To follow the course of freshwater is to trace the pulse of the planet itself. Rivers begin as humble streams, born from rainfall, snowmelt, or springs deep in the mountains. Gravity guides these waters downhill, carving valleys, transporting sediment, and shaping the terrain over millennia. Rivers such as the Nile, Amazon, Yangtze, and Mississippi have forged civilizations along their banks, providing irrigation, food, transport, and cultural identity. From the Himalayas to the Andes, rivers carry stories of geology, climate, and human history, connecting mountains to oceans and life to its source. Lakes, both natural and artificial, are reservoirs of biodiversity and memory. Glacial lakes, formed by retreating ice, hold crystal clear waters that reflect the sky and support diverse ecosystems. Rift lakes, such as Lake Tanganyika, host species found nowhere else on Earth. Lakes' moderate local climates store water for agriculture and act as vital buffers during droughts or floods. Each body of water is a unique ecosystem, balancing life, nutrients, and chemical cycles in ways that scientists are only beginning to fully understand. Freshwater is also crucial for life on a microscopic scale. Rivers and lakes teem with plankton, algae, bacteria, and small invertebrates that form the foundation of aquatic food webs. Fish, amphibians, birds, and mammals rely on these ecosystems for sustenance. Wetlands, marshes, and floodplains act as nurseries, filters, and sponges, regulating water flow, absorbing pollutants, and supporting countless species. Freshwater systems are hotspots of biodiversity, fragile yet resilient, shaped by both geological processes and climatic rhythms. The flow of water through rivers and lakes is intimately tied to climate. Seasonal rains, melting snow, and monsoon cycles dictate the rise and fall of river levels, influencing agriculture, human settlements, and ecosystem health. Floods can be destructive yet essential, depositing nutrient-rich sediment that enriches soils and sustains life. Droughts, by contrast, stress ecosystems, reduce freshwater availability, and challenge both humans and wildlife. The rhythm of freshwater mirrors the rhythm of Earth itself, dynamic, cyclical, and interconnected. Freshwater systems also bear the mark of human activity. Dams control rivers for energy and irrigation, but alter natural flow and disrupt ecosystems. Pollution, deforestation, and over-extraction threaten water quality and availability. Yet, communities worldwide have learned to manage water sustainably, drawing on traditional knowledge and modern science to balance human needs with ecological preservation. Rivers, lakes, and aquifers are not just resources. They are lifelines, their health a direct reflection of humanity's relationship with nature. Geologically, rivers and lakes are powerful agents of change. Rivers carve canyons, erode mountains, and deposit sediments across continents. Lakes trap nutrients and sediments, influence local weather, and shape landforms. Over millions of years, freshwater has sculpted valleys, carved gorges, and created fertile plains where civilizations thrive. The Mississippi Delta, the Ganges Basin, and the Nile Valley are monuments to the transformative power of moving water. Water is also a recorder of Earth's history. Sediment layers in lake beds preserve pollen, ash, and organic matter, revealing past climates, human activity and ecosystem changes. Rivers carry these sediments to oceans, where they become part of the geologic record. Every drop of fresh water participates in an endless cycle, moving from precipitation to river to ocean and back again, sustaining life and preserving memory. The beauty of freshwater is as profound as its utility. The reflective surface of a lake at dawn, the roar of a waterfall, the meander of a river through a forest. These landscapes inspire art, literature, and contemplation. They remind us of Earth's power, its serenity, and its generosity. Water connects life, reshapes landscapes, and carries the pulse of the planet from mountains to seas, from glaciers to aquifers. In understanding rivers, lakes, and freshwater systems, we come to appreciate Earth's interconnectedness. These life-giving waters demonstrate the balance of geological processes, climate systems, ecosystems, and human influence. They remind us that life thrives not in isolation, but through the continuous flow of energy and nutrients across landscapes. Fresh water is the lifeblood of Earth, a flowing testament to the dynamic, intricate, and enduring systems that sustain every living organism on this planet. From the highest mountains to the deepest ocean trenches, from dense tropical forests to arid deserts, life thrives on Earth in astonishing diversity. The biosphere encompasses all living organisms and the environments they inhabit, forming an interconnected web that binds the planet together. To understand Earth fully is to see it not merely as rock, water, and air, but as a living system where life and environment co-evolve, shaping one another over billions of years. Life on Earth began over 3.5 billion years ago with microscopic organisms in primordial oceans. Simple cells evolved into complex multicellular organisms, eventually giving rise to plants, animals, and fungi. Each evolutionary leap expanded the biosphere, increasing its complexity, resilience, and capacity to transform the planet. Photosynthetic life changed the atmosphere, creating oxygen. Animals transformed ecosystems through predation and symbiosis. Humans, in turn, have dramatically altered nearly every aspect of the biosphere through agriculture, urbanization, and industry. The biosphere is structured into ecosystems: forests, grasslands, wetlands, deserts, coral reefs, and tundras. Within these ecosystems, species interact in intricate ways: predator and prey, host and symbiont, pollinator and flower. Energy flows from the sun to plants, then through herbivores and carnivores, and finally to decomposers, completing the cycle. Nutrients are recycled through soils, water, and atmosphere, creating a continuous, interdependent network. The biosphere is not static. It is dynamic, responding to climate, geology, and human activity, constantly adapting and reorganizing. One of the most remarkable features of the biosphere is its resilience. Life persists in extreme conditions, from scorching deserts to frozen polar ice, from acidic volcanic lakes to deep-sea hydrothermal vents. Microorganisms flourish in radioactive waste, high-pressure ocean trenches, and dry rock surfaces. These extremophiles reveal life's adaptability and suggest that Earth's biosphere is far more versatile than we often imagine. Even ecosystems disrupted by natural disasters or human activity can recover, provided the underlying environmental conditions support renewal. Humans are both part of and apart from the biosphere. We rely on it for food, water, medicine, and raw materials. Our agriculture, fisheries, and forestry practices tap directly into the energy and nutrients cycled by other organisms. Yet our impact can be profound. Habitat destruction, pollution, overfishing, and climate change threaten countless species and destabilize ecosystems. Protecting the biosphere is not merely an ethical choice. It is essential for human survival, as we are inextricably bound to the health of the systems that sustain us. The biosphere also regulates Earth's climate and biogeochemical cycles. Forests absorb carbon dioxide and release oxygen. Oceans store heat and move nutrients. Soils harbor microorganisms that recycle nitrogen and phosphorus. Life itself shapes the planet, from the oxygenation of the atmosphere billions of years ago to the present-day influence of vegetation on rainfall and albedo. The biosphere is not passive. It is an active, evolving component of Earth's geophysical and chemical systems. Earth's biosphere is a testament to balance, complexity, and interconnectedness. It illustrates that life does not merely exist on a passive stage, but actively participates in shaping the planet. Species co-evolve, ecosystems adapt, and feedback loops maintain stability across vast scales of space and time. The extinction of one species can reverberate through the biosphere, altering ecosystems, nutrient cycles, and climate regulation, demonstrating the delicate equilibrium that sustains life. To explore the biosphere is to witness the miracle of existence. The synchronized flights of birds, the seasonal migrations of whales, the blooming of forests in spring, and the unseen microscopic dance of soil microbes all testify to the intricate web of life. Every organism, no matter how small, contributes to the function and resilience of the whole. The biosphere is a living network, resilient yet fragile, ancient yet ever-renewing, and profoundly interconnected. Understanding the biosphere imparts both awe and responsibility. Earth is not a collection of inert materials, but a dynamic, living entity, sustained by the interactions of countless organisms over billions of years. Protecting the biosphere is synonymous with preserving the conditions that allow life, including human life, to persist. It is a call to recognize our place within this vast, interconnected web and to act as stewards, ensuring that the living planet continues its extraordinary story. For millennia, humans have shaped the planet, transforming landscapes, modifying ecosystems, and altering the very chemistry of air, water, and soil. From the first controlled use of fire to modern cities stretching across continents, humanity has left an indelible mark on Earth. The scale and speed of our influence, particularly over the last 2 centuries, have made us a geological force, so much so that scientists refer to this era as the Anthropocene, a time when humans are the dominant drivers of planetary change. Early humans lived in relative harmony with nature, hunting, gathering, and later farming, modifying ecosystems in small but significant ways. Agriculture allowed societies to flourish. Forests were cleared to create arable land, and rivers were diverted for irrigation. With each advancement, humans increasingly controlled their environment, creating landscapes that reflected their needs, values, and technologies. Towns became cities, fields became industrial zones, rivers became sources of power and transport. Slowly, humanity began to exert influence on a global scale. Industrialization accelerated these changes exponentially. Fossil fuels powered factories, transportation, and urban expansion, releasing unprecedented amounts of carbon dioxide into the atmosphere. Mining reshaped mountains, extracted metals, and exposed new minerals. Chemicals entered rivers, soil, and air, altering ecosystems. Human settlements fragmented habitats, driving species to extinction and reducing biodiversity. The planet's cycles, carbon, nitrogen, water, began to reflect human activity as much as natural processes. Urbanization transformed Earth's surface. Cities, sprawling across thousands of square kilometers, created heat islands, modified wind and rainfall patterns, and concentrated waste and pollutants. Transportation networks connected continents but fragmented landscapes, changing the movement of wildlife and the dispersal of seeds. Yet cities are also centers of innovation, culture, and stewardship. They exemplify the dual nature of human impact, destructive in scale, yet capable of problem solving and regeneration. Human activity has also altered climate on a global scale. The burning of fossil fuels, deforestation, and industrial emissions have raised atmospheric temperatures, changed precipitation patterns, and increased the frequency of extreme weather events. Glaciers retreat, sea levels rise, oceans acidify, and ecosystems struggle to adapt. Humans have become both creators and disruptors of environmental conditions that once evolved over millennia. Our choices now dictate the trajectory of the planet's climate and the survival of countless species. Yet humans are not solely agents of destruction. Conservation, restoration, and sustainable management demonstrate our capacity to heal the Earth. Reforestation projects, protected areas, renewable energy adoption, and pollution mitigation are examples of intentional, informed interventions that preserve ecosystems and biodiversity. Ecological understanding, guided by science, allows humans to reduce negative impacts and enhance resilience in both natural and human systems. The Anthropocene is defined by responsibility as much as power. Humans possess the ability to drive species extinct, change climates, and reshape landscapes, but we also hold the capacity to restore rivers, protect forests, and stabilize ecosystems. Our actions ripple across the biosphere, affecting species thousands of kilometers away, altering ocean currents, and even influencing global carbon cycles. Recognizing our interconnectedness with the planet is essential to surviving and thriving within it. Human impact is evident in nearly every corner of Earth. From the plastic accumulating in oceans to the nitrogen-enriched soils of farmland, from the warming Arctic to the sprawling cities of Asia and America, our presence is undeniable. But so is our potential to act as stewards. Understanding the consequences of our actions, informed by science and guided by ethics, allows humanity to participate consciously in the story of Earth rather than dominate or destroy it. In essence, humans are both observers and participants in Earth's dynamic systems. We are a species capable of awe, innovation, and destruction, whose choices reverberate across ecosystems and climates. By embracing knowledge, responsibility, and stewardship, we can ensure that our influence becomes a force for sustainability, resilience, and life, rather than chaos. Human impact is the newest chapter in Earth's story, and how we write it will determine the fate of the planet for generations to come. As we stand on the threshold of tomorrow, Earth's story continues to unfold. The planet is a dynamic, interconnected system, shaped by forces both ancient and immediate, from tectonic shifts to glacial melt, from ocean currents to human activity. The decisions made in the coming decades will determine the trajectory of life, climate, and ecosystems for centuries to come. To envision the future of Earth is to confront both challenges and opportunities, to acknowledge vulnerability while embracing the potential for resilience. Climate change is perhaps the defining issue of this era. Rising global temperatures, caused by greenhouse gas emissions, are altering weather patterns, melting ice sheets, acidifying oceans, and threatening biodiversity. Extreme weather events, hurricanes, floods, heat waves, and droughts are increasing in frequency and intensity, disrupting human societies and natural ecosystems alike. Yet, even in the face of these challenges, science provides a roadmap. Renewable energy, carbon capture, reforestation, and sustainable agriculture can mitigate impacts and help stabilize the planet's climate system. Human population growth, urbanization, and resource consumption continue to place pressure on Earth's systems. Freshwater scarcity, soil degradation, deforestation, and overfishing highlight the interconnectedness of environmental issues. Yet humans are also agents of adaptation. Technological innovation, conservation strategies, and global cooperation can create solutions that balance human needs with ecological sustainability. Earth's future depends on our ability to harmonize development with stewardship, science with policy, and knowledge with action. Biodiversity will play a critical role in shaping resilience. Ecosystems rich in species and genetic diversity are better able to withstand disturbances, recover from natural disasters, and provide essential services such as pollination, water filtration, and carbon storage. Protecting and restoring habitats, connecting fragmented landscapes, and curbing extinction rates will be essential to maintaining a stable biosphere. The survival of countless species, including humans, depends on the health of these intricate networks of life. Technological advancements offer unprecedented opportunities to monitor, understand, and respond to Earth's changing systems. Satellite observation tracks deforestation, ice melt, and ocean currents in real time. Climate models simulate future scenarios, guiding policy decisions. Artificial intelligence, renewable energy innovations, and ecological restoration techniques empower humanity to act with precision and foresight. Yet technology is only as effective as our collective will to use it responsibly, emphasizing that knowledge alone is insufficient without ethical stewardship. Education and global awareness are equally important. Communities that understand the science of Earth systems are better equipped to adapt, mitigate risks, and embrace sustainable practices. Empowering people with knowledge fosters resilience, innovation, and a sense of shared responsibility. From local conservation initiatives to international climate agreements, collective action is essential to shaping a future in which Earth remains habitable, vibrant, and full of life. Earth's future is also intertwined with cultural and societal values. How humans relate to nature, perceive their place within ecosystems, and value biodiversity will influence the choices made in governance, economics, and development. Recognizing Earth not merely as a resource, but as a complex living system fosters respect, humility, and responsibility. Sustainable futures arise from ethical engagement, informed policy, and a deep understanding of interdependence. Yet even amidst uncertainty, Earth has demonstrated resilience over billions of years. Ice ages, volcanic eruptions, asteroid impacts, and mass extinctions have reshaped the planet, but life has persisted, adapted, and flourished anew. Humanity now plays a pivotal role in determining whether the planet will continue to support the intricate web of life. Our actions, local and global, individual and collective, will write the next chapters in Earth's history. The vision of Earth's future is one of balance, between human development and ecological integrity, between technological progress and environmental responsibility, between immediate needs and long-term sustainability. It is a call to action, a challenge to harmonize our species with the rhythms of the planet. The stakes are immense, but so is our capacity for ingenuity, compassion, and stewardship. As we gaze forward, we are reminded that Earth's story is ongoing. The mountains will continue to rise, glaciers will flow and melt, rivers will carve valleys, and oceans will pulse with life. Within this dynamic, evolving world, humans have both a responsibility and an opportunity to participate consciously in the stewardship of the planet, ensuring that life, in all its diversity and resilience, continues to thrive for generations to come. As we step back and view our planet in its entirety, Earth emerges not as a static backdrop for life, but as a dynamic living system, a world in constant motion, shaped by fire and ice, water and wind, life and time. Mountains rise and crumble, glaciers carve valleys, rivers weave intricate pathways, oceans pulse with energy, and life itself adapts, evolves, and thrives. From the smallest microbe in a soil particle to the largest whale in the oceans, every element participates in the extraordinary story of this planet. Earth is a testament to interconnectedness. Its lithosphere, hydrosphere, atmosphere, and biosphere are intertwined in a delicate, complex web. A change in one system resonates through the others. Melting glaciers alter ocean currents, deforestation affects rainfall and carbon cycles, volcanic eruptions can shift climates and transform landscapes. These processes remind us that we are not separate from the planet. We are part of its rhythm, intimately connected to its cycles and systems. Humanity stands at a pivotal point in Earth's narrative. We are the only species capable of reshaping the planet at a global scale, for better or worse. Our innovations, cities, and technologies have enabled unprecedented growth and knowledge, yet they also carry profound responsibility. The choices we make today, how we use resources, conserve biodiversity, harness energy, and respond to climate change, will determine the state of Earth for generations to come. We are both stewards and participants, capable of protecting the delicate balance that sustains life or accelerating its disruption. Earth's beauty and resilience are awe-inspiring. The shimmer of sunlight on oceans, the silent majesty of glaciers, the ceaseless flow of rivers, the explosive power of volcanoes, the quiet hum of forests, all are manifestations of a planet alive with energy and history. These forces have shaped life itself and continue to provide the conditions necessary for survival. Our awe must translate into action to preserve, respect, and restore, ensuring that Earth systems continue to function and flourish. The story of Earth is a story of time, motion, and life. Billions of years of transformation have produced mountains, valleys, oceans, and an intricate tapestry of living organisms. We witness this story not only in the grandeur of landscapes or the complexity of ecosystems, but also in the subtle interactions, the pollination of a flower, the migration of birds, the ebb and flow of tides. Every element is connected, every action has consequences, and every life contributes to the ongoing narrative. In the end, Earth is more than a planet. It is a living home, fragile yet resilient, ancient yet ever renewing. Its future is not predetermined. It is a reflection of the choices we make, the respect we cultivate, and the understanding we embrace. By cherishing its landscapes, protecting its biodiversity, and honoring the intricate systems that sustain life, we participate in the most profound act, the continuation of Earth's extraordinary story. Let us remember that we inherit not just a planet, but a living, breathing world full of wonder, mystery, and life. Earth is our shared home, a magnificent, dynamic entity, and the responsibility and privilege of caring for it belongs to us all. The mountains will continue to rise, rivers will continue to carve valleys, glaciers will flow, oceans will pulse, and life will endure, but only if we act with wisdom, compassion, and foresight. Earth's story is ours to witness, ours to protect, and ours to continue. It is a story of resilience, connection, and life itself, a story billions of years in the making, still unfolding and waiting for the next chapter. We are part of it, and how we choose to participate will echo for generations, shaping not just our future, but the future of this living, magnificent planet we call home. Thanks for drifting with me around our peaceful blue planet. We explored how Earth's formation and delicate balance create the perfect cradle for life, reminding us just how remarkable our home truly is. If this gentle journey helped you unwind, please like, subscribe, and leave a calm comment sharing what you'd love to explore next. And if you'd like to keep relaxing, watch another Sleepy Science Facts video and drift even deeper into nature's soothing mysteries. Rest easy, traveler.